Okay, seventh grade, this is what your vocabulary sheet should look like. It's 2 pages here in front of me. Yours would be front and back. So on this side of the vocabulary, you can see I've already put in some of the definitions. These are the type of number systems you're actually going to learn about more in the next video, but I will go through them quickly here. Whole numbers, you have probably heard of these before. Whole numbers are your no decimals, no fractions, there's no negatives. It's a whole number, has no part to it. So you don't have a mixed number, it's not 1.1. The first whole number is actually 0, and this would be what you can add into your notes. And then 1, 2, 3, 4, 5, 6, on and on and on forever. That dot, dot, dot means forever. So this, another whole number would be the number 1,236,789. That is a whole number. It's an incredibly large one, but it is a whole number. Then we move into integers. Integers are like whole numbers and their opposites. So basically it's all of these numbers and negative numbers. A lot of times we think of them as the ones on the number line. We can still have no decimals or fractions here. So you would have -5, -4, -3, -2, -1, 0, 1, 2, 3. Those are still there. And I'm going to do a dot, dot, dot on that side because it would go on forever, both directions. Then we get to our rational numbers. Rational numbers are now we can have decimals and fractions. So they are all of these, and now we can have decimals and fractions. But they have to be a decimal that could be written as a fraction. So for example, 0.5 can also be written as 1/2. They're the same thing. So 0.5 is a rational number. 1.45 is a rational number. A whole number like 7 is a rational number because I could put 7 over top of 1 and now it can be written as a fraction. And real numbers, simply put, are all the numbers you know. Decimals, fractions, negative, positive, everything. Okay? Now, how do you know when you look at a decimal that it could be written as a fraction and then in fact it is a rational number? There are numbers out there that are not rational. How you know is if the decimal is what we call a repeating decimal or a terminating decimal. Oops. And we're going to go into those on your next page. So over here, we're going to talk about what is a repeating decimal. And it is just that. It is a decimal. So we have that decimal number that goes on forever. It never, ever ends. It goes on forever and ever and ever and ever and ever. But a number repeats. So for example, we might have 0.33333333, that dot, dot, dot means forever. So this is the number 3 repeating, going on forever and ever and ever and ever. Okay, another example could be 0.166666, so on and so forth. Now, this one's a little different because we have that number 1 that does not repeat, but then the 6's after it does. So again, it goes on forever and a number repeats itself. We could also have 0.513, 513, 513, 513. It does not have to be a single digit that repeats, just a number. So in this case, it's 513 that repeats itself over and over and over again. So any number that's repeating like this can be written as a fraction and is considered a rational number. A repetend, you can see I've written this in here, is the symbol above a number that shows it repeats. We do not want to write this out all the time and always write dot, dot, dot. So there is a shortcut to writing these 3 repeating decimals, and here's what it is. 0.3 with a little slash above the 3. That tells me that 3 would look like this and would go on forever. So I know that this decimal would in reality be 0.333333333, but I don't have to sit there and write out all the 3's. We say this 0.3 repetend. Okay, so that dash above it is called a repetend, and that just tells me it goes on and on forever. Notice in this one, that repetend symbol is only above the 6 because up here, it is only the number 6 that is repeating itself. I do not have it above the 0 or the 1. So that tells me this decimal would be 0.16666 on and on and on forever. Here, you can see that I have the repetend over the entire number 513 to tell me that it's 513 that repeats, like up here. So that's the repetend is just a symbol we use to let us know that that decimal repeats. A terminating decimal, which was the other type of decimal we know would be a rational number, very simply, it is a decimal that ends. These are the decimals you are more familiar. 0.5. It ends. It does not go on forever. There is no dot, dot, dot. 1.45, like I did on the other sheet. It ends. It stops after the 4, 5. 0.987654321. It's a long decimal, but it does end after the 1. There is no dot, dot. There is no repetend sign. All of these decimals could be written as a fraction, and so are considered rational numbers. They are terminating decimals. Finally, opposites doesn't really have anything to do with a decimal number, but opposites is a positive and negative number the same distance from 0 on a number line. So for example, 5 would be 5, that's the positive, would be 5 spots away from 0 on a number line, and then negative 5 would be its opposite because it is also 5 spots away from 0 on the other number line. I don't want to say it's the same number because 5 and negative 5 are not the same number. We could say it's the same digit or same sequence of digits with one being positive and one being negative. In terms of decimals, 1.34, negative 1.34 are opposites. I could start with the negative. Negative 1/2 and positive 1/2 are opposites. So opposites can be any number, any real number. It's just the positive and negative of it. And that is all you need to know for vocab.